So tonight's content is about number theory, positive, negative, even, odd, absolute values, factors, multiples, remainders, prime numbers, and prime factorization. So all the kind of the basic building blocks of arithmetic, essentially. So positive and negative numbers. Positive means greater than 0. Negative means less than 0. 0 is neither positive nor negative. So just as a little FYI, on a question where they use a word like non-negative, what most people do is they sort of automatically associate that with the word positive. That's not correct. Non-negative does not mean positive. Non-negative means something is not negative. So that means it could be positive or it could be equal to 0. Okay. And then likewise for non-positive, non-positive also includes 0. Okay. But on a question like this, you definitely need to think about 0 as a possibility, not just positive numbers. Okay. Rules of positive and negative. I'm not going to go through these with you guys too detailed. I think you know them already. Positive times positive is positive. Positive times negative is negative. And negative times negative is positive. And then multiplication and division are basically the same as far as those rules go. For addition and subtraction, there really are no nice rules. Even and odd exponents. So just be aware that if you have an even exponent and you try to solve for x, you will get both positive and negative. You'll get either positive 2 or negative 2. Okay. I'm also going to mention a little detail that I realize some people don't know. If they give you a radical sign, a square root like this, then you get positive only. Okay. So there's a slight difference here between using the square and using the radical. With the square, when you solve it, you will get both positive and negative. With a radical, you get the positive solution only. With odd exponents, it's kind of different. If I know that x cubed is equal to 8, then x will be equal to positive 2, and it will be positive 2 only. Of course, the other possibility is I might have something like this, like x cubed is equal to negative 8, and when you solve this, x will be negative 2, and again, only negative 2. Okay. All right, so problem number 1 is asking you how many integers are there that satisfy this equation. And I'm going to set the time now for 1.5 minutes or 90 seconds and let you guys do a calculation here to see if you can find all the integers. Oh, my bad. What is an integer? So the word integer includes 0, it includes whole numbers, and it also includes the negatives of the whole numbers. Okay, so -1, -2, -3. So integers include both positive, negative, and 0. Just no decimals, no fractions, no crap like that. Okay, good luck. Okay, time's up. So please have your answer ready, A, B, C, D, or E. And I'm going to launch the poll so you can choose, cast your vote. Okay. So it looks like E is the clear front runner with 63%, and we have some votes for A, B, and D as well. Okay. So with the problem here, I would not necessarily try to be too clever. So I'd like to write down some symbol to represent what the question is asking for. When they ask me for the number of things, like how many things, I use capital N, just because it's, to me, it kind of reminds me of like the population and statistics. And so then I want to think about what X could be. And I'm going to make kind of a quick table here of what happens with X plus 1, X plus 3, and X plus 5. Okay, and in particular whether that's more than 0 or not. So we need to pick integers that are less than 5. So the first number would be 4. So what you can see really quickly is that you're going to get a positive number here, a positive number here, and a positive number here. The specific values actually don't matter that much. You're going to get a 5, 7, and, well, it doesn't really matter, a 9, I guess. But when you multiply positive times positive times positive, you're going to get a positive value. And then you can see really quickly that the same thing's going to happen for 3, 2, and 1. They're all going to give the same basic outcome. Then you get the number 0. So here I'm going to actually use the values just to remind myself of what's happening. So I'm going to have 0 plus 1, 0 plus 3, 0 plus 5. So I still have positive times positive times positive. The result will still be positive. Now we have to keep on diving down into negative numbers. And I can try negative 1. So with negative 1, what will happen is I'll get 0. For this first piece, negative 1 plus 1 will be equal to 0. The other pieces actually don't matter. It doesn't matter whether they're positive or negative, because 0 times anything is 0. So I'm just going to ignore those for now. Since the entire product is 0, this symbol does say greater than or equal to. That would actually be OK as well. Now I'm just going to keep on moving along, and I'm going to try negative 2 next. But something weird is going to happen. So I'm going to get negative here. I'm going to have positive here, and then positive here. So negative 2 will not give me a number that's... actually, we can do the values. This will be negative 1. This will be positive 1. This will be positive 3. So this one's actually not going to work. And if you wrote it down before, you definitely should cross out the negative 2. It's not possible. Negative 3 will work. For kind of the same reason that negative 1 does. It'll make this middle piece of 0. That gives you another possible value. I can try negative 4. This one you got to think a little bit harder. So you have negative 3, negative 1, and then a positive 1. So negative times negative is positive. Then I have another positive here. That means the result will be positive. So this one's kind of a surprise. I didn't really see it coming, but it does definitely fit the pattern. Then negative 5 will give us 0 for this piece. And again, we don't care what the other two pieces are because 0 times anything is 0. So that will work. At this point, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. And so that looks like I've run out of all possible options. I don't have to go any further because E9 is the last possible number anyway. So we can just stop here and we can pick E and we're happy. If you picked A, it means you probably didn't try negative numbers. If you picked D, it means you probably did negative 1, negative 3, and negative 5, but you skipped negative 2 and negative 4. You've got to test those also. All right, you got to test until completion, basically. Okay. So let me show you. Let me try to show you a data sufficiency example. Well, I was aimed, but there's no other possible values. So what are the ones I came up with? 4, 3, 2, 1, 0, negative 1, negative 3, negative 4 is the surprising one, and negative 5, and that's it. So on the upper end, we can't go numbers that are On the positive side, we can't go to numbers more than 4 because of this condition. If I try to a number that's even smaller, like -6, then what I'm going to get is negative. Well, of course. Well, Alexander says negative 10, but I can do -6. Then I'll have -5 times -3 times -1. But that result will be negative. So negative times negative is positive, then times one more negative, yeah. Nope, it's fine. So it's kind of one way you could plan this question in advance a little bit would be to think about the possible ways you can do this. So it could be all positives, it could be 2 negatives and 1 positive, or it could be anything involving 0, right? So if you can kind of plan in advance what the possible solutions are going to be. Yep. All right. So the next example